The International System of Units is a way for the world to have the same system in order to easily share information and share measurements. Now, what you'll notice is that the United States does not use the metric system. They do not use the system international, is what they call it. So there are 3 countries in the world that do not use the metric system, and we, the United States, are not one of them. However, in science, we do use the metric system. What you need to know are the 3 basic base units for the International System of Units. So, what are they? Well, you've got 3 of them, and most of you are familiar. Meter is the System International for length. Second one is liter, which would be the SI unit for volume. And number 3, gram, would be the SI unit for mass. Meter is for length, liter is for volume, and gram is for mass. Now, I wanted to show you this metric conversion. We don't cover this until the next unit, but you can actually add prefixes. So this is a chart of the metric prefixes. Now, this isn't in your notes right now, but I do want to hint at it because you may be familiar with some of the prefixes. In the middle, you have your base units. Here they are, 1, 2, and 3. We just covered them. But did you know that you can add prefixes to change the value? For instance, if you have a meter, that's the base unit. But what if you have this may look familiar, a millimeter? Well, that's 1,000 times smaller. Or a centimeter. You may recognize centi. And then gram is for weight, but what if you had a kilogram? It's 1,000 times bigger. So this chart we'll visit later, but it actually tells you that you can change the value of a metric prefix simply based on the prefix that's used. Temperature. We use Celsius in science mostly. There's also Fahrenheit and Kelvin. Temperature is a measurement of the average kinetic energy of a system. It measures how fast the molecules are moving, and we call that heat energy sometimes, which we'll learn about later down the road. There are a few temperature scales. The first one that we look at in science is Celsius, but it's not the only one. Celsius scale was set because of water. Water, when it freezes, they put that at 0. And when water boils, they put that at 100. And then from there, the Celsius scale was set. Kelvin is based on something called absolute zero. Kelvin is on a lower scale because it takes into account absolute zero, which is the point at which all motion theoretically ceases. So if you were to take a gas, the molecules are moving fast, and if you were to start to slow the molecules down, cool the temperature, and start to freeze it, eventually you would reach 0 Kelvin, and then the molecules would be completely still, which in real life is not possible. We can't get the molecules to stay still. It just doesn't happen. We need to know how to convert between Kelvin and Celsius because we see these 2 temperature scales the most. We do not use Fahrenheit in our class, although we use it in America all the time. Here's the equation for converting Celsius into Kelvin. We have to add 273 degrees. At negative 273 degrees, we get a 0 value for Kelvin. We call this absolute zero. So let's do an example. Let's convert 25 degrees Celsius into Kelvin. Here's our equation. We would plug in 25 degrees Celsius here. All we got to do is add 273. It'll be the easiest equation you learn all year. We get 298 Kelvin. That would be your final answer. And it's not degrees Kelvin. It's just Kelvin, and that's it.